Okay, what we'll talk about here is degeneracy. Degenerate solutions. And we'll work off the same example that we have used extensively. X1, X2 are tables and chairs. And we have a constraint that looks like that, and a constraint that looks like that. And we have these four basic feasible solutions. And let's just list here X1, X2, X3, X4. And what we have is we have four corner points, A, B, C, D. And what we have is at A we have X1 and X2 0, and we have X3 and X4 are positive. We're far away from the constraints. And at B, we'll have X1 at 0, we'll have X2 as being positive, now it's come positive, and X3, which is associated with the first constraint, will go to 0, and X4 will still be positive. And at, so this is the point A, and this is the point A, and this is the point B. And now we go to C and then to D. At C and D, we have both of these positive and both of these 0. And at point D, we'll have this will still be positive, but X2 will be 0. And then the other, the constraint, this will be positive and that will be 0. So we see at all times there are two variables that are positive. This is positive and that's positive. We have 2. So the basis is always a set of positive values. Should those values ever be 0, then we have a degenerate solution. How might that happen? Well, let's put up a new page here. And that might happen if we have one constraint that looks like that, and we have the other constraint that might look like this. Now, we don't know that when we're solving our simplex, so we have X1 here and X2 there, and you'll notice that here, if we have now A, B, C, we will have at A, we will have X1, X2, X3, X4, because there will still be slack variables for each of those. I think I better move things over a little bit. So we have X1, X2, X3, X4, and we have point A, we have X1 and X2 0, and both the slack variables will be positive. When we go to point B, what happens is that we have X1 goes to 0, X2 goes positive, but both values of the constraints will go 0. And this is called a degenerate solution, because what you expect is you expect to have two basic variables. And it turns out that when you do the simplex method, you will observe that a basic variable can take on a 0 value. And when that happens, that you have the list of basic variables, you have your B and your N, and you'll see that there's a variable in the basis, but its value is 0, then you have a degenerate solution. And within the context of this course, when you're solving linear programs by hand, this may be a little bit surprising when this happens, but there is no consequence. It can cause numerical problems which are readily resolved, and that's dealt with in more advanced courses. But within the context of this course, degenerate solutions don't present a problem. They're just a little odd. Now, what happens is that what we need to say is that in network problems, it occurs very often. We encounter degenerate solutions very frequently. All the time. And this may seem a little odd, but there's some preparation required, so I can now say I told you so, and that's one aspect that I just wanted to make sure that we had talked a little bit about, so you remember what a degenerate solution is. It means that a basic variable takes on a zero value.